Researchers recently handed a frontier AI a real iOS app, a bank account with $350, and 24 hours to grow the business autonomously. Under deadline pressure, the agent panicked. It slashed the price 6 times to zero, while buying fake engagement and spamming users. By day's end, the AI burned 320 million words of processing and 1,000 actions, ending with a net financial loss. This failure reveals a miscalculation in how the tech industry approaches digital workers. New research shows that a simple 2-step AI process scored 86% on a math benchmark, while a complex 5-agent system using the same model only managed 45% at 7 times the cost. Stacking layers of artificial intelligence often compounds errors rather than solving them. This obsession with over-engineering has created expensive, unpredictable systems, ending the pursuit of a fully autonomous digital agent that works without human supervision. For an AI to handle complex, multi-day work, it has to remember past instructions. Today, long-term memory remains a critical, unsolved bottleneck in model development. Current systems struggle to retrieve the right information at the right time. In precision tests, agents often successfully store data, but fail to grab the specific facts needed to answer a query correctly. Even when researchers perfectly organize an AI's files, it only reduces the computing bill. Tidier memory makes the system cheaper to run, but it doesn't make the AI's answers any smarter. Without reliable retrieval, these agents remain trapped as short-term novelties rather than dependable digital employees. These models are also prone to sycophancy. They will often ignore facts or even lie just to agree with a confident user statement. To fix these behavioral flaws, engineers are turning to a technology from the early 2000s, ontologies. Ontologies are rigid maps of entities and logic. They act as unbreakable guardrails, forcing the AI's probabilistic reasoning to follow a set of deterministic rules. We are moving away from an era of vibe coding, where developers relied on vague prompts. The industry is returning to the discipline of formal software engineering. For AI to be trusted with business operations, its guessing must be caged inside these hard, enforceable rules. Running the largest frontier models is physically and economically expensive. These data centers consume massive amounts of power just to handle basic, routine tasks. But we are seeing a shift towards specialized models. A tiny 0.6 billion parameter model recently outperformed the giants in industrial tuning, achieving a 94% success rate on its first attempt. Innovations like 4-bit math have also reduced the precision needed for training. This allows models to learn using a quarter of the usual compute power without a significant drop in accuracy. This collapse in cost is reaching the consumer. OpenAI has split its flagship model into 3 pricing tiers, allowing users to pay only for the level of intelligence they actually need. This chart shows the new pricing floor. While the flagship model costs $5 per million words, the new Luna tier handles routine tasks for just 20 cents. The industry is consolidating around highly specialized utility-level intelligence that is almost free to run. This cheaper, more disciplined intelligence is finally moving from the cloud into physical machines. Google DeepMind's Gemini Robotics 2 provides a shared intelligence layer for robots. It allows different machines to coordinate and hand off parts of a task, rather than just repeating pre-programmed motions. But as AI moves into the real world, it faces an immovable barrier: legal liability. The GCC project, which manages the compiler behind Linux, has banned meaningful AI-generated code. To avoid copyright risk and legal contamination, they refuse to accept contributions that aren't written by humans. The pursuit of total autonomy has given way to a network of cheap, specialized tools, judged strictly by their economic cost per task.